So finally, we are on our last type of chemical reaction. So we've gone through synthesis, decomposition, single replacement, double replacement, and now we are on to combustion reactions. So combustion reactions is going to be some sort of chemical compound, typically something that has carbon and hydrogen, that reacts with oxygen to produce some sort of energy. Usually it's something like a fire, and carbon dioxide and water. So the basic, if you want to know the basic outline of every combustion reaction, it typically has some sort of carbon and hydrogen mixed, some type of carbon-hydrogen molecule added to oxygen gas to give you carbon dioxide and water. So it is always going to give you these two things as a product every single time, no matter what these little x's are. Now these little x's can be any number, but it will change how you balance it. That's the only difference. So if you look at this example right here, you have the complete combustion of, hey look, here's our carbon and hydrogen with some sort of oxygen gas, you know, that stuff you breathe, to give you CO2 and H2O. In addition to those two products, you also get this cool little flame here. That is the heat that we were talking about. Gasoline also does this as well. So gasoline is a mixture of these hydrocarbons, meaning that they have carbon and hydrogens all over the place. So if you want the complete combustion of gasoline, you are going to have your carbon compound. Remember, this is our CXHX idea, but now we've replaced those X's with numbers, and this is what changes our coefficients. And then it was added to oxygen. So remember, we had it added to some sort of oxygen to give CO2 and water. This is the basis of every combustion reaction. So let's take a look at one type of wax that has a formula of C25H53. See, those X's could be any number. It says that it reacts with oxygen in the air. So what do you think it's going to happen? So remember, this must be some sort of combustion reaction. Take a look at just our reactants. So it said that our wax reacts with, that's hard to say, oxygen. Automatically, these two reactants should remind you of the general formula for a combustion reaction. So you should know that it produces the two products of carbon dioxide and water. So you can predict the products of all these different types of equations just from knowing what two things are being added together. So this candle wax undergoes combustion, and it has these humongous coefficients. Okay, that one's not that big, but look at how big these are. They're really big. The reason for that is it changes based on these coefficients right here. So those coefficients are going to dictate what our coefficients of oxygen, carbon dioxide, and water there are. But the nice thing is it always forms the exact same thing every single time. So if you wanted to write the reaction equation of this alcohol lamp that uses ethanol as fluid, we could write the equation for a combustion reaction because we just need to know what carbon-hydrogen compound we're putting in. So if we were to take our C2H6O, that's our ethanol. Remember, every time it's a combustion reaction, it is reacting with O2 gas. And on top of that, it's going to give us CO2 and water every single time. Now, to balance this equation, once again, you're going to want to draw that table to make sure that we have everything balanced out. But the products are always going to be the same, carbon dioxide and water. So let's take a look and see how many carbons we start with, how many hydrogens and oxygens, and then we'll balance. Okay, so we automatically can see that we have one less carbon here on the right, so let's make that a 2, make it a little bit bigger. That's going to change 2 of our elements that we're working with because there are 2 different ones in our compound here. So 2 times our subscript of 1 is going to give you 2 carbons, and 2 times our subscript of 2 is going to give us 4 oxygens in that compound, but don't forget you have 1 over here in water as well to give you a total of 5. Now let's take a look at our excuse me, our hydrogen situation. So we definitely need more hydrogens here on the right side in our product side. So what coefficient would get this little 2 over to 6 like we have on the reactant side? I think 3 is our best option. So 3 times our subscript of 2 will give you 6, but that also changes how many oxygens you have. So you have 4 from our carbon dioxide and another 3 from our water to give you a total of 7. Now we need to balance out our oxygen on the reactant side, and we are all done because our carbons both are equal, our hydrogens are equal. Now let's balance our oxygens. So how would we get this 3 all the way up to 7? Well, I don't want to interact with this molecule here on the left because that's going to change all of our carbons and hydrogens. Instead, I want to start increasing the number of oxygen by itself to get it up to 7. So we want to get whatever number plus 1 up to 7 because our original compound our explosive compound has 1 oxygen as well. So I think I would want to have 6. So we would use a coefficient of 3, which would give us a total of 6 oxygens from the product of just oxygen gas, plus our 1 from our alcohol lamp to give us a total of 7. So overall we have all of our elements balanced and it is all set. And if you want to see that laid out a little bit neater, we have our 3 to 3 coefficients right here that are all balanced. And now at the end of your notes, there are some great reminders of what different type of reactions we've used. This one is your combustion reaction, and it also gives you a great example as well as the general equation. This is true of all of the different types of chemical reactions that we went through. Here's our decomposition, our single replacement, and double replacement. And see how, remember, we're breaking apart our positive and negative ions here. And finally, our combustion. Now, remember, they are going to use these general formulas, and they do use different letters, but it's okay. They still work and are the exact same idea. You can use whatever letters you want to memorize the different types of chemical reactions. And then, of course, we have the general layout of our key concepts as well as our key vocab words for the chapter. All right, that's it for me, and we're finally done with chapter 11.